Okay, good morning. So we are at this time we'll tackle now the limits of the piecewise function and the slope of the tangent line. Okay. So first we will have an example for getting the limits of the piecewise function given that we have here f of x is equal to we have negative x minus 4 as x approaches 2. We have x is less than or equal to negative 2, while we have here negative 3 and we're given that x is greater than negative 2. Okay? So how do we find the limits of this given function? So actually, the limits of the piecewise function exist if the limit from the left and the right hand sides are equal. Okay? So we could easily figure out the limits from the left and the limits from the right by looking into the x value we're in this value approaches. No? So x is less than or equal to negative 2, so it means that from the left, no? From the left or to the left, no? X is greater than negative 2 or to the right because greater than. Okay? So let us have this one. Okay, so therefore, we have here the letter A, limit of negative x minus 4 as x approaches 2. We have here negative 2. So we have here negative 2 because this one is less than or equal to, that is to the left. Okay, as a bar sa tabaw, it signifies that to the left and yung curve. So when we evaluate this one, when x negative 2, so that will become negative times negative 2 minus 4, and that is equal to 2 minus 4, the answer is negative. Okay, for letter B, we have here this one, limit of negative 3 as x approaches 2. We have here greater than negative 2. So negative 2, but this one is greater than, therefore to the right. Okay, to the right. So to solve for this one or simplify, we can now have use the property of the limit, no, or limit laws. Limit of c as x approaches to a, the answer is in the number or c, the constant. So to evaluate the limit, this one is just equal to negative 3. Remember that since that limit from a is not equal the limit since the limit from a is not equal the limit of b. Okay, kung saan na yun? Therefore the limit does not exist. So very simple. Okay? The limit does not exist since we have here evaluated a given piecewise function from the left, this one, and from the right, and we found out that the value negative 3 is not equal to negative 2. Okay? So therefore, since the limit from A is not equal the limit of B, the value is not equal, so therefore the limit does not exist. So very simple. Okay, so we have here the second example. We have limits of piecewise function. Manata, then we will now continue for the slope of, or finding the slope of the tangent line. So example number 2, find the slope of the tangent line from f of x is equal to square root of x, then given that x is equal to 4. Okay? So our concern is only the slope of the tangent line. So the process is, first we will have to get the derivative of the given function. After we get the derivative of the given function, we will have to use the value of x, which is 4. No? Then the resulting value that signifies to the slope of the tangent line. Okay? So we will have to get the derivative of f of x. No? Okay? So we have here f of x is equal to square root of x. First, we have to get the derivative using the Okay, limit of x plus delta x is this one, no? Square root x, or the x in here, we will replace this one by x plus delta x. So we have here x plus delta x minus fx which is square root of x, over, we have here delta x. Then as delta x approaches to 0. Okay? Remember, we cannot simplify this one by just plugging this value which is 0, okay, into the delta x, because this function become undefined. Okay? So what we are going to do is we will have to multiply this each of this numerator and denominator by the conjugate of the numerator. So multiply natin siya sa iyang conjugate. This will become limit of the quantity square root of x plus delta x, okay, minus square root of x, okay, over delta x multiplied by, okay, we have square root of x plus delta x, okay, conjugate minus 3, so plus 3 plus square root of x, okay, over square root of x plus delta x, okay, plus square root of x, okay. Then we have here as delta x approaches to 0. Okay, next. Okay, we will have to multiply, so that will become, we have here limit of, pag multiply natin, that will become x plus delta x. Okay, difference of 2 square man. Matanggal niya mga square root ani, so magbigay minus x. Over, ang sa ilalong, okay, that will become, okay, delta x multiplied by square root of x plus delta x. Okay? Then we have here plus square root of x. Then as delta x approaches to 0. Okay, we have x and negative x become 0. So the remaining value is delta x. So we have here limit of delta x over delta x multiplied by square root of x plus delta x, okay, plus square root of x. Okay? Kuha natin ito. Okay? As x or as delta x approaches to, okay, as delta x approaches to 0. So actually this one is cancel out. This one. So nabiling sa ibabaw or in the numerator, we have here limit of 1 over square root of x plus delta x plus square root of x. Okay? As delta x approaches to 0. Okay, again, simplify this one. That is just actually equivalent to, okay, we have here, if we're going to get the limit of the constant, the answer is still the constant, which is 1. So 1 is ibabaw. Okay, over square root of x, square root of x plus delta x. Si delta x, we will have to replace this one by 0. So that will become x plus 0. Okay, si delta x, 0 man siya, which is 0. Plus, we have here square root of x. So the remaining, we have here 1 over square root of x. X plus 0 is x plus square root of x. Okay? The answer is we have here 1 over 2 times square root of x. Okay? We are not yet done because this is just only the derivative. What we're going to find out is the slope of the tangent line. Provided that x is equal to 4. So if x is equal to 4, okay, therefore f of 4 is equal to 1 over 2 times square root of 4, and that is equivalent to 1 over 2 times square root of times the square root of 4 is 2, so the answer is 1 over 4. Okay, this one is what we call as the slope of tangent line. Okay, slope of the tangent line. So I hope that this example will help you, okay, studying about the limits of the piecewise function and the concept of derivative, or the introductory part of the derivative. Actually, this answer, okay, I will show to you on how we're going to derive this the derivative of the square root of x. Very long solution kanino. Square root of x become 1 over square root of 2 times 1 over 2 times square root of x. So I will give you, okay, or I will show you on how to calculate the derivative of square root of x. Na may mo siya 1 over 2 times square root of x using a very short solution. Okay? So let me erase this one. Okay? For the short solution, okay, we have here, we will have to use the formula for the derivative of f of x, or if you're given f of x is equal to x to the power of n, therefore the derivative is f prime of x is equal to n times x to the power of n minus 1. So this will be the formula for the direct method. So let us have this one. Okay? We have here f of x. F of x is equal to square root of x. First, we will have to simplify that one into rational exponent. Rational exponent, so we have x to the power of 1 half. Kaya square root lang sa 1 half. Then its derivative is we have here f prime of x is actually equal to 1 over 2. May naog mas ito, i-times 3. Times x to the power of 1 half minus 1. Okay? 1 half minus 1. So that is just equal to 1 over 2 times x to the power 1 half minus 1 is negative 1 half. Okay? Or that is just equal to 1 over 2 times x para mahimo siya positive, pailalo na ito, mahimo siya positive, negative man siya. After that, our final answer is we have the derivative of f of x. Okay, we have here 1 over 2 times x to the power of 1 half. Ano? Square root of x. We have square root of x. A very short solution for getting the derivative of the rational, radical function. No? So take note of this formula. You can always use this one whenever you want to find the derivative of any function.